Well guys, got to do some snow blowing here. Bouncing dog. So I'm all bundled up here. It's about, I don't know what it is, -11. And I plugged this thing in about 4 hours ago. So I'll connect up my booster batteries and we'll see if we can get this thing to go. And once that's done, I'll get some work done on that adapter for the Chief there. See how that goes. You hear the inline heater hissing away as it's circulating water through the block. So let's get to it. Okay, so we got our booster battery and our booster charger all hooked up and ready to go here. Set to start. If I get that right, it should start pretty quickly and easily. See how we go here. Not much to see, not much to point at. I think that fitting right there is where the glow plug is supposed to be. Right here, this one. But there isn't one. Somebody mentioned that at one point. I don't see anything else in there that would look like it could possibly be one. Anyways, we'll put you right there and hope you don't fall off. I don't even know what you're looking at, and we'll see what we have here. Okay. There you go, that started easy. First try. So we'll take all this apart, put it away, put the lid back on, let this thing warm up, and we'll do some snow blowing. Well, we're done snow blowing here. We're pretty much done. Had some bad luck though. The throttle shaft actually shattered, as you can see there. I'll have to get a new one of those when I can. Everything's closed tomorrow supposedly. I was hitting it with the white lithium grease because everything was sticking, and the stuff I had to heat it up with the kerosene diesel heater there because I think it was like a lump of butter in there. Oh well, at least they got pretty much done. It wasn't too bad out there. Anyways, let's get on to doing some real work here. See if we can't crank out an adapter. So I'll top up the fluid here. Obviously got nothing in it right now. I'm just using motor oil. I never heard any different. You know, there might be something better. I don't see that it's going to be a big deal. Anyways, let's top this guy up and then we'll start work on the adapter. Okay, so here's an existing Endmill holder, R8. I think I've shown this one before. And looking at how deep the shank of the of a 1/2-inch Endmill would go into here, looks like it would go about 1.625 inches. So what I want to do is I want to create a headpiece that'll be about 1 3/4 inches long, and then we'll have a tail piece that's the length of a JT2 holder here. So about here to there, which looks to be, I've got my good old caliper handy. Let's have a quick look. Excuse me, it looks like it's about 1 inch. Yeah, we're right around 1 inch there. So we're going to end up doing a holder that's going to be about 2 3/4 inches long. So I'm going to buck this piece off here and let's get doing something here. Now if this doesn't work for you, Chief, I can always make another. I'm off again tomorrow. I don't imagine it's going to take me too long to make one, so I could always make another one. Okay, we'll face off this end here. I've taken a couple of cuts already here. I'm taking about a 1/10 cut. Using a little bit of this stuff for cutting fluid. And as somebody pointed out previously, if there's any of a little bit of a nib left behind, that probably means that my tool is set a little bit too high or too low. So I can always just adjust that. Yeah, you can see just a bit of a nib there. Now I took it off. So I'll take about a 5/10 cut and clean it up. It seems to be cutting fairly evenly there. I probably should have pulled the tool back a bit, but kind of hard to do this while you're, you know, especially with your good hand here. Face this puppy off. That's a 5/10 cut this time. Then I'll probably take a cleanup cut. Yeah, I can't crank this very well holding with one hand. I really should be using both. I can do it nice and evenly. You can see kind of the roughness of this. This is 1018 steel, which is supposed to be pretty free machining, so it should have a nice finish, but no worries here. I'll take this one dry. I'll take about a 2/10 cut. This isn't going to be very interesting to anybody who's a real machinist, but some of the guys had said that they'd like to see the operations as they're going on. Yeah, it's a lot cleaner, because I'm also cranking a lot slower. You can actually see a pretty good reflection in it. Now I really shouldn't drag the tool back across what I've been cut, but nevertheless, it'll leave a big spiral on the end. Take another 2/10 cut just for the hell of it. Anyways, you guys get the idea. Okay, so what I haven't shown right now is that I flipped this around. I faced this off to 2.75 inches. Center drilled this side. I'd also center drilled the other side that I hadn't shown. And now what I'm going to do is I'm going to bore this whole thing out to about a 1/2 inch. That's what it's basically going to look like. The JT2 taper at the, you know, at the smallest portion of it is actually slightly smaller than 1/2 inch, but at the topmost section it's you know, 0.55 of an inch. And actually, if I bore the whole thing out to 1/2 inch, I only lose just a very tiny amount of the taper at that end, so I don't think it's going to be a big deal. So I'm going to get to this. I don't know if I have a boring bar that will fit in there, but we'll see how we go. I'll do it with drills first, and then we'll see how we go with our boring bars here. Because the ones I have to use are these ones right here. Yeah, well, yeah, that's not going to be a problem. It's just going to be a problem finding one that will actually fit in the bore. That one should. Anyways, let's get to it. Okay, so I've drilled this thing out all the way through to what would it have been? It was one step short of 31/64ths, and then I reamed it out to 31/64ths, which is 0.484. And now I'm just wanting to see what the concentricity was like, because I couldn't bore it out. I don't have any boring bars that are both long enough to fit in there, and that will even fit in the hole that size, you know, just under 1/2 inch. So I put the test indicator on here. I wanted to see what the concentricity was like, and we'll go from there. Now, obviously, I'm testing this end. I don't know what it is at the chuck end. It might be worse, might be better. Who knows? But if we rotate it through, you know, to the worst case scenario, that's right about the worst case scenario. So it looks like there's about 3 thou of runout on this. So hopefully that's going to be acceptable. That's probably about as good as I can do right now, until I get some better boring bars. If I get a boring bar, I could have done a lot better job, but that's not the case right now. So what I'm going to do now is I'm going to set up the compound to cut the JT2 taper, and I'll run that into there, cut that, and then what I'll do is I'll flip this thing around and I'll ream it out to a full 1/2 inch, or I'll check the runout on that end as well, but it'll be a little bit less accurate, because you really need the runout compared to how it is in the taper. So I'm going to have to be a little creative there to test that. But what I'll do is I'll, when I've done cutting this JT2 taper on this end, I'll ream this end out to 1/2 inch, or I'll check the runout first. I don't know. We'll go from there. We'll see how we go. I had to shut that damn thing off. It just kept running and running and running. The temperature is 15 Celsius in here. which is like 60 Fahrenheit. That's plenty warm enough for me, especially when I'm wearing snowmobile pants and a sweatshirt. Anyways, enough bitching. I've got the, here, I might as well take this off. We can have a quick look at it. I've got the compound set over so that it should have about the right taper. It's really hard because it's such a short shank. It's difficult to get a good, you know, range there. So hopefully it'll fit well. If not, maybe you might be able to lap it in with some sandpaper, like by wrapping sandpaper around your spindle end, you know, and just driving it into the unit there and seeing how that goes. I could actually even try that here as well. Let's see how it goes. We'll use some really fine grit stuff before I try it, but I don't know how well that's going to work, so blah blah. Anyways, I've got it set over. I bored a little bit in there. Here's my test, and we can see that we're only going in about that far, so I'm going to take another 5 thou cut, and we'll go from there. When it starts to get close, I'll start taking 1 thou cuts to clean up that bore there, and we'll go from there. I suppose I could go and put this together and we could do a quick shot of this thing going here, but it's really hard to do because I do need both hands to operate the compound for a good even speed. I guess we can do it for one. Yeah, it's really hard to do with one hand. Well, we got lots more material to remove, so it's not going to be a problem. You can still hear it cutting. Okay, it stopped cutting. So I'll bring it back slowly. Believe it or not, backing it out is easier than advancing it in. Anyways, I'll show you the finished result. Okay, so I tried to do a little bit of 220 on wrapped around the end of this, you know, like, and insert in there, but that wouldn't work. That worked about as well as it would have sounded like it would. But seems to be fitting in there. I'm feeling a little bit of play, but when I tapped it on with the mallet, that went away. Now, granted, that's possibly because it's holding it firmly, but nevertheless. So I think that should work. I'm tempted to take a little more off because obviously you can see that the taper isn't seating all the way in there. But from that rust line that's there, that's how much it was sitting into my chuck anyway. So I'm a little reluctant to take a little more off. And like I said, you might be able to lap it in there with some valve grinding compound. You know, just work the two together, and it may help. You know, like, there's no guarantees, but it's worth a try, certainly. I suppose I could test the concentricity of this by seeing how much this wibble wobbles. We can turn it on and just see. Yeah, there's a little bit of noticeable wobble there, eh? I'll go and grab a dial indicator or test indicator and just see what we can figure out here. Okay, so I just checked the runout at the end. Now, granted, it's exaggerated by the fact that it's way out, you know, at the end here, but I was getting about 10 thou of runout here. So it may not be great. I suppose it'll be serviceable. I'm not exactly proud of it, but you can try it, and we'll see how it goes. I guess at this point I'm going to flip it around. I'm going to ream it out to half an inch, 1.65 deep, and then I'll just turn a little bit of just some, you know, bevel on it, and then I'll see about putting some set screws in this thing here. So, anyways, let's get to it. Okay, that's reamed out to a half inch. Yeah. Just a little bit of play there. I should try it in one of... I don't have a half-inch Endmill holder, actually. I think it's a little more than I would have expected. And that was with a reamer. That was a half-inch reamer, and unless that half-inch reamer is slightly oversized or this shank is slightly undersized. So I could try another one. I'll try this one. Yeah, there's still a little bit of play in there. Not particularly happy. I'll test it with a one of my expandable indicators there. I did find those things. There they are. There. I'll get back to you in a second. Okay, I checked, and it according to the telescopic gauge, it's telling me it's about 2.5 thou over. So once again, I'm a little annoyed, but we'll see if we can make this serviceable. I can't really add any material to it, but we'll put the set screws in all the way around, and that will help at least somewhat. Anyways, okay, I'm putting a taper on the end of this just for ornamental purposes to make it easier to get into tighter places here. So it's a 45-degree angle. I'm taking 10 thou off every time, and I'm just using the manual cross feed to do it. Okay, surface finish. Anyways, there's just one for the one for people who like to see something actually happening, not the result. Okay, I've taken a little sandpaper, cleaned it up, and so what I'm going to do now is I want to mark 3 spots about, I'll have to measure how far in it is, or the end it is on this one here, but 3 spots at whatever this distance is. It looks to be about 1 inch around the circumference of this unit here, and I just have to figure out how I can do that fairly accurately. Oh, I think I'm going to make this again. I'm going to give it another try tomorrow. Tomorrow's a holiday up here. It's called Family Day, and I'm going to give this another try. And I think this time I'm going to see if I got a boring bar. I don't need a boring bar that'll go the full, 2 3/4 inches. I just need one that'll go like about 1 like 1.65 is what I was saying before. And if I got one that'll go that, then I'll bore this next time, and I'll try as hard as I can to get it exactly to half an inch rather than 0.5025, which is what that telescoping gauge was telling me. I'm a little annoyed about that. Like the taper on the back is a little bit harder to do, and you can kind of compensate for that. But this one here is just kind of pissed me off. That reamer, like a 1/2 inch reamer should give you 1/2 inch, a 1/2 inch hole, but it wasn't. So, anyways, I'll deal with that, and I'll show you the results of that. Okay, I cheated a bit. I butted this edge up against here, moved it back 3/4 inch, and just ran the lathe and just gently touched it with the cross slide to make a mark at the 3/4 inch distance, which is how far back that one was from the edge. And then I just went and by sight aligned the jaws of the 3-jaw chuck, roughly level, and then just ran the compound back and forth, and that's what I did to mark those out. So I'll center punch those, and then I'll put that in the mill and drill those out to, I think I've got some 3/8 inch set screws. I nearly trip over all the shit on the floor here. Yeah, there we go. Got a bunch of 1/4 inch set screws actually. I think those will be fine. I think that's what's in the other one. No, that actually is a much bigger size one. I'll have to look and see. I don't think I have any that big, but I'll check it out and see. Okay, just so I can describe the setup that I've done here. What I'm going to do is I have set up the vise such that I indicated off the, it's not very good there, it's going to fall into the hole if I don't hold it down right, but I've indicated off the back of the vise, I've moved this way 3/4 inch, and I've indicated off this edge of the vise, and I moved 3/4 that way, which I should put this about where I want it. This is 1.5 inch piece of stock. So all I have to do is just butt the edge of the unit up to the edge of the vise here, and I'll do that with a straight edge, or probably a parallel, because it's nice and flat. Let's clean that off, and that just makes it easier. So you just have to rotate, loosen the vise, and rotate this to the appropriate position, line it up underneath the center drill, and I can that can correctly you know, drill a hole on this guy here. This is just kind of quick and dirty stuff here, and I've been watching a lot of tubal cane videos. It's Mr. Pete, I think 222. If that's wrong, I'll put something, you know, up in the corner here to tell you that. But a lot of that stuff is quick and dirty for something that's kind of quick and dirty. But anyways, let's do this because it's 8 o'clock and dinner is in the oven. There we go. So one Endmill holder, JT2 on that end, more or less, and 1/2 inch on this end, plus, you know, 2.5 thou. 3 set screws at 120 degrees spaced out, 3/4 inch from the end. So seems to be holding that fairly well. It remains to be seen how well it's going to work. Let me know what you think there, Chief. Anyways, I'm going to knock off for the day. Thanks for watching, guys.